we're going to be given a piecewise defined function, and there's a couple different varieties, but it depends on how the rule is expressed to us. That we've got a couple of ways that we can go to plot and graph these lines. What I would encourage you to do when you have a rule that has a lower bound, a left and right bound, lower and upper bound on the domain, I would take the left hand number and plug it in and find a coordinate. So basically I want to know -4 comma what should be a dot for this f of x function. And to do that, I plug it in to this -2x minus 4 rule. And so I figure out what is -2 parentheses and then -4. I plug in the -4 in there for x. So this was my 2x minus 4 coming on over right here. And then you work it out, and that's going to give you -2 times -4 would give you +8. -4 should give you 4. So this coordinate, -4, 4, is where this function touches utilizing this top piece rule, this top linear rule. And so I'm going to plot that dot by clicking here in a minute. I'm just going to circle it for now to know where I'm going to click later. So -4, 4. I'm going to put a dot there in a minute. And then I want to do the same process for this rightmost part of the domain. Now, technically, I don't plug -1 into this. I don't actually have -1 defined at all. There's going to be a hole, though, where that spot would be. So I go ahead and I do plug it in just like I did a moment ago in where the -4 was. And so I'm going to just erase that spot and substitute my -1. So plugging in -1 now, -2 times -1 is +2, and +2 minus 4 should be -2 is my output. So that output gives me a coordinate of -1 comma -2. That spot, -1, -2, is going to get a hole in just a moment that I'm going to click. So now I'm going to go through and actually click that and drag. So I'm going to click right here and then drag down, hold the click and drag down to -2, -1, -2. And then what I want to do is leave this as a solid dot because I'm including with the less than or equal to on the -4, but then -1 is not included, so I actually click that and make that a hole. So I just find the two endpoints, click and drag, and then I have my line segment that represents that spot. Now I'm going to do the same process, but it's a lot easier because there's something to plug into on the second interval. So the second interval is essentially two coordinates, -1 comma, the output is always 2, so -1, 2, and then to 4 comma 2. So I'm going to take and graph a line from -1, 2 to 4, 2. And everywhere on here, there's going to be a horizontal line at a height of 2. I'm just not going to include the -1 value, and then I'm not going to include also, again, the 4 value. So just click and drag, and there should be a line appearing, and then I just make sure I click and make those open dots to have holes. So this is the piecewise defined function here, and I've graphed the two different pieces using the endpoints as my guide. All right, so for this next example, it doesn't at the outset look more difficult. It kind of looks the same. You got a linear and a constant. The issue is the way that we're given the rule. The rule says we're supposed to use a y height of 5 for everything left of 1. So essentially, I take the 1 as my endpoint, and I'm going to have a coordinate of 5 for my y output, and that's where I start. I start at 1, 5. And then everything left of that, that's what this arrow does. This arrow means everything to the left of this dot uses that rule. The rule is the y height is 5. So what is needing to happen is I need a line that's going to head off that direction. So I'm going to go ahead and click that in there. So I'm going to click the 1, 5, and then drag off to the left a horizontal line y height of 5. Now the way that this program works is you actually just take this leftmost dot and click it once and you get a hole, and you click it again and you get an arrow. You can actually take it back off. You click it a third time, it's back to the solid dot. So click once, click twice, and then now we've got this line that's heading off to the left. That's a constant, a graph of a constant function. And we got to be careful though, because here that I circled this 1, 5 is not included if you look at the function rule. So I got to make sure I come back over here and click that and make that a hole. And then I turn my attention to this second graph. Now, the second graph, the way we are trained early in our math career is to just go ahead and graph it by using the slope-intercept form. This is an m of 1, and the y-intercept, the b value is 3. So I would have started at 3, rise 1, run 1, and start heading off to the right. The issue, though, is we're not supposed to use that graph until we hit 4. So rather than start at the y-intercept of 3 and then rise 1, run 1, what we can do is very simply plug in 4 as my starting value. So I need the coordinate that connects to this x value of 4. So I plug in, I've got my x plus 3, and I make the x become a 4 plus 3, and the output would be 7. So the coordinate 4, comma 7 is where I start this function because the 4 is my input, and then running the function through, the output produced a 7. So I'm going to start at 4, 7. And then from there, I'm going to rise 1, run 1, rise 1, run 1. You only have to do it once with this generator. So I'm just going to click at that 4, 7 and then drag up 1 over 1. And you see the line happening. You can do it twice if you like, but you only have to do it once. And then it's going to be an arrow because everything left of 4 is supposed to use that rule. So we just click that dot and it turns into a hole. Click it one more time and we get the arrow. Because everything to the right, because this says greater than, that means everything to the right of 4 uses this rule. So now everything that I've done together makes the picture of this piecewise defined function. Nothing is defined. This function is not defined in the middle here. The domain goes from negative infinity to 1 and then picks up again at 4 and heads off to infinity. That's how that rule, that's what graph the rule produces. And we want to make sure that we do, in fact, open that hole at 4 because the rule does not include the 4. So the rule goes negative infinity to 1, not including the 1, and then again picking up just after 4 to infinity. So now we take those prior skills of starting at the endpoint and really get tricky because as we know, we're not going to be able to start at 4 and then do my slope to graph this line. We have to start at negative 1, so it's a little bit different. We could have gauged it by drawing it, and you could do that on pencil and paper. But what I'm going to recommend is that you start at the 1 and plug it into this function. I know we're not supposed to include the negative 1 because there's no equal to sign there, but we still want to know where would it start with a hole. So we plug in negative 1 to this function, negative 2 x plus 4. You put the negative 1 in there where the x goes. So negative 2 times negative 1 plus 4. And then work it out. That gives you positive 2 plus 4 is 6. So the first coordinate for this function, actually the rightmost coordinate, is negative 1 comma 6. What I mean by that, the last one, is that when I plot this point, negative 1, 6, this is the end of a line. Now, here's the deal. That negative 2 is my slope. I need a negative slope that's going toward this function. What's going to happen is people consistently, no matter how many times I say, hey guys, this is going to happen, it still happens. And our brain says, oh, I'm supposed to go to the left and I need negative slope. So our brain says, oh, you go down and left and that'll get me negative slope. And then they've graphed it. And then we don't pay attention to is this is actually positive slope. This is wrong. That is not the right thing. Do not go down and left and think that you're making negative slope. We have to go from left to right down to get negative slope. We have to be going down to get negative slope. This is a negative m. So to get that correct on my graph, I have to start at this coordinate, rise 2, and then run 1 to the left. That's a negative 2 slope. When m equals negative 2, that's what I'm looking for. So I'm going to use the generator now to go ahead and click at this negative 1, 6. And then I'm going to rise 1, 2, run 1. And then it's kind of clustered behind the drawings that I have there. So let me erase that so you can see it. And then we go ahead and click the arrow once, twice. And that means that it's coming down. It's falling now and ending at 6. And then this, negative 1, 6. And then I'm going to open that dot because I'm not supposed to touch that dot at the end. So that means I go down and right. That's negative slope. Please do not go up and to the right. If you go up and to the right, it's positive slope. So now, moving to the right side, I need to start and pick up at 3. So I actually skip the y-axis and I pick up over here at an x value of 3 somewhere. So where that is depends on what happens when I plug it in. So I'm going to do similar work here. So I'm just going to go ahead and erase what I've done so far and take this 3 and plug it into this rule, the bottom rule. Even though we're not supposed to actually use 3, it's a hole there. I want to know where that hole starts. So I go negative 5x plus 19, and I'm going to plug the 3 in for x. So negative 5 times 3 plus 19. I need to work that out. It's going to give me negative 15 plus 19, which gives me 4. So the first coordinate, the hole that I start at, is at 3, 4. So I plot that dot at 3, 4. Put a nice little hole right there. And then from that dot, I need a slope of negative 5. So a slope of negative 5 is going to cause me to go down 1, 2, 3, 4, 5 from there, and then over 1. And so that's going to connect to the dot there, and it's going to pick up and keep going. So I'm going to go ahead and use the generator now to click this dot and go down 5, right 1 for my slope of negative 5. And then I'm going to click that twice to get my arrow because I need it to continue to go to the right because my rule says you continue on that path all the way for infinity. Now, the only other trick is I got to catch this 3 is a hole. I don't include the 3. So these are my two pieces. And again, the biggest trick that most people make a mistake on is this left-hand side. When we have a negative slope, it's just our brain says, oh, you got to go down, but it's actually going up. And this is negative slope. As you read the graph from left to right, your pencil should, or your finger should fall down if you have negative slope as it continues to fall down. You see this side negative slope, and people, I have had so many students, they have this negative 2 here, and they go up and then down, even though they're both negative. They should go the same trend if they have negative slope. So now we're going to play with 2 lines, but both of these lines have bounded endpoints. So what I would encourage you to do is anytime you have these bounds on both ends is to just go ahead and plug them in and find the exact coordinate where they start and end. So I'm going to plug in the negative 4 with this x plus 7 function, plug in the negative 4 to it, and that's negative 4 plus 7 will produce a 3. So I get a coordinate at negative 4, 3. That's the starting point, and then my ending point, I do the same work, x plus 7. I plug in the negative 1, and that's going to be negative 1 plus 7, which produces a 6. So I get a coordinate of negative 1, 6. So then I plot those 2 dots, negative 4, 3, and then I'm going to get a negative 1, 6. And use the generator, paying attention to the endpoints. At negative 4, I'm going to want a hole eventually. I'll take care of that in a second. And then at negative 1, I end right there with a solid dot. So I make a hole here and then solid dot based on the fact that this is not included at negative 4 here, and then this is included at the negative 1 here. So down to the second one, the second rule, I'm going to start back at negative 1 again and go ahead and plug it into this second part. And again, I know negative 1 is not actually defined here, but we still want to know where would that hole start us. So x plus 4 is the new rule, and I plug negative 1 into it. So negative 1 plus 4 gives me 3. So the coordinate negative 1, 3 is where a new hole will be in just a moment. So negative 1, 3. And then I plug in the 3 and get the same process, x plus 4, plugging in a 3 in there. And so then I get 3 plus 4 is 7. So that makes this graph go 3, 7 with a solid dot there. So 3 to 7, 3, 7, and you put a solid dot on that one. With the generator here, I'm going to go click there, click that one, open dot at negative 1, solid dot at positive 3, and this is the graph of this piecewise function. So now we've got a constant and a linear function. I picked this one because a lot of students get really stressed out when they see just an x hanging out there. It's like we forget what to do with x. The x line is supposed to be the line that goes through the diagonal of all the grid lines. That's the slope of 1, y-intercept of 0. That's what the graph looks like. Of course, it's all blue there. Now we have red. That's what the graph looks like. But we're only using the part of it that starts at negative 4. So essentially, I want all of this part to disappear to my graph when I do it over here. So I'll take care of that by graphing it in just a moment. But let's pick up and think through what we were doing earlier, which is you start with the -4 and you plug it in to x. And if x goes and gets replaced by -4, the output is -4. So the coordinate here is -4, -4. I put the -4 in there, and it spits out a -4. So what I intend for that to mean is down here on the graph, I'm going to have a dot right there, and then the slope is positive. And so what that means is the slope would have went up and to the right, but we're actually going left, so we need to go down and to the left. So what would have been rise 1, run 1 needs to be fall 1, left 1. -1, -1 still produces a up positive slope if you're going up. So if you're going up, it's positive, positive. Down, it's negative, negative. It's still a slope of -1. So we just got to go to the left is why that's a bit confusing for people. So we're going to click on that dot and make it happen. -4, -4. And then we're going to just slide down 1, left 1. And notice again, this is trending up to the right, even though it's just a line segment. So I'm going to click the end here twice, and now that arrow shows that it falls forever to the left on the diagonal, and then it stops at its highest height at -4, -4. So this coordinate ends it. And then I want to make sure I put a open dot at the end because it does not include the -4. So that's what the left-hand side of the graph looks like. And then moving to the right, everything after that should be a horizontal line at a height, a constant of 1. And it was starting here, picking up at 5. So way over here at 5, you're going to go y height of 1 and then take off to the right. So let's use the generator to do that. And I click right there and then drag to the right. And then if you just click this dot twice, you get the arrow. And we need an open dot at that beginning because we don't actually include the 5. And again, the biggest trick for that is people really mess up going to the left on that X, this piece right here. Make sure you're going down and left, and that's still a positive slope. If you're going down and left, it's okay. It's still positive slope. So now we've got two different lines, and they're going at two different rules. So both directions, they're going to be arrows, one to the left, one to the right. This x plus 8, it doesn't even touch the y-axis, so I really got to pay attention to what y height I start with, and that is going to be produced by the -4. So I take my x plus 8, as I did earlier, and I'm going to plug in -4 to it. -4 plus 8 spits out a 4. So the coordinate -4, 4 is my initial value. So -4, 4 would be right here. And then from there, I need a positive 1 slope. So I just use this rule to find the starting value and to know that I'm going to the left is what that says. X is less than. So I'm going left with it, but I need a line with a slope of 1. Well, going left with a slope of 1 would look like down 1, left 1, down 1, left 1. That will produce a positive slope, positive 1 slope if I go down left. So it's negative, negative. Essentially, as you're going down and left, a -1 divided by a -1 is a positive 1 slope. So down and left produces that positive slope. So now I'm going to use the generator to actually make it happen. Click this dot, go down 1, left 1, and then I'm going to click it twice to get that arrow to shoot off. And then I'm going to make sure that this is a open dot. I think we had, I can't see with I'm going to erase my work up there so that this is not included. So it's a hole at the end. Very same work moving off to the right. I'm going to start with the 1 and plug it into this function, -x plus 9. Plug in the 1, and you get -1 plus 9, which gives you an 8. So the coordinate 1, 8 is where I start. And then from there, I need a slope of -1. So I'm going to go down 1, right 1. So I click at 1, 8, down 1, right 1. You can do it twice if you like, down 1, right 1. Click it twice to get the arrow to appear, and then make sure you have an open dot to begin with. And that is the graph of this piecewise defined function. Now, one final example here. Again, the key is we're going to have starting at 1, and we're taking off to the left with a negative slope. So that's cause for concern for many people. Frequently asked questions is whenever I have a negative slope heading to the left. So let's start, as I have been. We got negative 3x plus 9. I'm going to figure out what coordinate to start with by plugging in this 1 in for x. So negative 3 times 1 plus 9 should give me 6. So the first coordinate I plot is 1, 6. I plot 1, 6 right here. And then from there, what I need to know is that my slope of negative 3 is equal to negative 3 over 1, or it's 3 over negative 1. So I can rise down 3 and then go right 1, or I could go up 3 and left 1. That's the difference between these variations. So this would mean down and then right, and this one means up and then left. This is the one I need to utilize because I'm heading left. So this is how I have to play. So from this dot, I need to go up 1, 2, 3, and left 1. That's how I need to plot this line. That's a lesser used skill because in Math 1, we're usually focused on going to the right. So I click this dot and go rise 1, 2, 3, left 1. And then I'm going to click that dot twice to get the arrow to appear because it needs to continue to take off to the left there. And then this dot needs to be whole at x equals 1. So let me go ahead and erase the other writing that I have. There we go. So now you can see the whole line there. So now we're going to do the same work starting with 5. So if I plug in 5 to negative x plus 14, it's going to look like 5 going right here. Negative 5 plus 14 should produce a 9. So what that means is my coordinate is 5, 9. And the 9 got from there. So I plot this dot 5, 9. And then I use my slope of negative 1 to go down 1, right 1. And notice how the trend is in the same direction as the previous line, so that I'm going down from left to right. So you can do it twice if you like, or once, doesn't matter. Click that end arrow to get the arrow. And then this should be a open dot to begin with. And we have the piecewise defined function graphed.